Hello, everyone. We are Team 3 from ME452, and this is our analysis and redesign of a sim racing steering wheel. The product that we will be redesigning is a sim racing steering wheel. Sim racing is an ever-growing video game genre based around racing cars in a virtual world. These drivers use the steering wheel attached to an external console with an encoder to drive the car in that virtual world, and there's a variety of buttons and dials used to tune the car to their tastes. The components include a base plate, which is the largest component of the car. Attached to the base plate are four grips for the hands of the driver. We are also including a quick release to quickly release the wheel from the encoder and console, and there is a wedge to adjust the angle relative to the driver. Also included are multiple buttons and dials so that the driver can control the car.
Our customer base, we're looking at primary customers being sim racing gamers and our secondary customers being race teams or research institutions. Based on different global racing games like Project Cars and Assetto Corsa, we're estimating a demand of 100,000 units per year. Breaking down our functional analysis, our task function is to control the car. Our primary functions are steer car, change mode. Our secondary functions are rotate encoder, transmit signal, sense input, and select gear. Our supporting functions are to detach encoder, support customization, provide feedback, and comfort hands.
Using our list of components, we are able to create two assembly diagrams. Shown here is our first assembly sequence. We start with the base plate because it is the biggest and most central component. Then the four grips are attached, followed by the three mounting top hats, mounting wedge, quick release shaft, and quick release slider. Afterwards, all 8 buttons are attached, followed by the PCB box. To finish the assembly, the 4 dials are installed. Similar to our first sequence, our second sequence starts with the base plate. However, there's the addition of a subassembly. The subassembly consists of the quick release shaft, quick release slider, and mounting wedge. After the subassembly is attached to the base plate, we then attach the mounting top hats, buttons, PCB box, and dials. Then the sequence is finished by installing the 4 grips. When reviewing our 2 assembly sequences, it is evident that the addition of a subassembly and sequence 2 makes assembly much more efficient and easy, yielding a total score of 12 points. Sequence 1 falls behind due to its lack of options for subassembly testing and parallel assembly, resulting in a score of 9 points.
Here's our functional component mapping matrix. As you can see, all the components are listed on the left, and all of our functional requirements are listed at the top. Comfort hands is the functional requirement that is touched on the most by all of our components, and the components that touch on the most functional requirements are the quick release shaft, the quick release slider, and the 2 buttons and dials.
We created this BOM as a baseline that can be compared to a future redesign. Processing time was determined using DFA charts. The cost of that time was assumed to be the average labor rate of $23 an hour. The other manufacturing processes were determined using hubs.com, assuming a 20% profit margin. Altogether, the material processing and tooling cost is a little over $126, 100 of which was just the carbon, which is a big area of improvement for us looking on. It's also important to note the process is also entirely manual, and by estimating using DFA charts, the assembly time adds up to 244 seconds, where the number of fasteners stands as the single greatest contributor at 156 seconds.
As you can see on the previous slide, the current price for the steering wheel is $126.11. Compared to products that are currently on the market, which range from about $250 to $300, and assuming that these products are marked up from their assembly costs, we can assume that we are within range, and further developments in our manufacturing and assembly techniques will yield greater profits moving forward.
We classify the components by their importance and cost. Based on the car chart, DFMA will be applied to redesign the quick release shaft and slider. And also, we are going to redesign the base plate and mount wedge to be produced by materials that are less expensive and require less processing time.
A lot of the parts used for both steering wheels are the same to maintain commonality between them. The main difference between the 2 products is that the gaming steering wheel and the functional requirements for the steering wheel don't need the buttons or dials that the racing teams require for their steering wheel. And this can be seen on the next slide with with the two CAD models. This is the updated version of the previously mentioned assembly sequence for both steering wheels. Using delayed differentiation, we were able to optimize the commonality between both steering wheels, therefore optimizing the assembly sequence.